This is exam number 2 review, question number 18. We need to find the exact value of cosine 195. Cosine 195 is basically equal to cosine 150 plus 45. 195 is not one of the regular angles that we deal with in the unit circle, so we need to turn it into a sum or a difference of two angles that we already know. So the first that come to mind is this one, and using the sum formula for cosine, this is cosine 150 cosine 45 minus sine 150 sine 45, and then you're going to look at the unit circle and plug in the values. Similar for tangent, so tangent 7 pi over 12. 7 pi over 12 is not on the unit circle, so we're going to try to split it into two equations, angles, such that the sum or the difference is going to be angles that we already know. So tangent, I know 7 is 3 plus 4, and the reason why I chose 3 plus 4 instead of 5 plus 2 is because 3 and 2 are one of the factors of 12, so I can reduce the fraction later and come up with an angle that works. So 3 pi over 12 plus 4 pi over 12, which is going to be tangent of pi over 4 plus pi over 3, which is equal to tangent pi over 4 plus tangent pi over 3 over 1 minus tangent pi over 4 tangent pi over 3. And then you plug in the values and find the final answer. Simplify square root of negative 75 first. So we're going to follow PEMDAS, which is inner inside of the parentheses first, and then we will do the exponents next. So to simplify what's inside the parentheses, I'm going to bring out the negative as I. So it's going to become I square root of 75. And then when you square both of them, this is equal to I squared times square root of 75 squared. The square will cancel that. We know I squared is negative, so this is going to be negative 75. Subtraction, this is not very difficult, so we subtract the real parts together. The real parts, 12 minus 4, 8, and then we subtract the imaginary parts. 2i minus negative 3i is equal to 2i plus 3i, which is 5i. The conjugate for 5 minus 6i is 5 plus 6i. We'll just change the imaginary part sign. To simplify a division problem that involves a complex number, we need to multiply by the conjugate of the denominator, both numerator and denominator. So this becomes 2 over 4 minus 5i times 4 plus 5i, 4 plus 5i. So this is equal to 2 times 4 plus 5i over 16 plus 25, which is equal to 8 plus 10i over 41. You split it or leave it like that, doesn't really matter that much. And then simplify I to the 24th power plus I to the 99th power. I'm just going to show one of these and then skip the rest. 24 is basically a multiple of 4, that is 6 times 4, so I know immediately that this is I to the 4th power raised to the 6th power, which is equal to 1. So this term is equal to 1. Plus 99. I know that 99 divided by 4 is 24.75. So I can rewrite this as I to the 96, which is 24 times 4, times I to the 3rd power. So this becomes 1. So this becomes negative 1. And then you finish the rest same. So 36 is going to be 1 because I know that's a multiple of 4. 43 is going to become negative 1. And then times 3 is going to be negative 3. And then you find the final answer. Question 24 is not part of the exam, so I'm just going to skip that one. Question number 25, it's an application problem. Outside temperature over a day can be modeled as a sinusoidal function. Suppose you know that temperature is 85 degrees at midnight, and the high and low temperature during the day are 98 and 72 degrees respectively. Assuming T is the temperature of the number of hours since midnight, find an equation for the temperature D in terms of T. So the first thing I do here is to graph, or to show just a graph of what it would look like. So this line is going to be midnight. So this is going to be the midnight line. And then over one day, it's going to be 24 hours. Half of that is 12 hours, which is going to be noon. And then at 6 a.m., this is the low. And then at 6 p.m., it's going to be the high, which is the mid-distance between midnight and noon, and noon and midnight again. We know that the temperature at midnight is going to be 85 degrees. So 85 is right here. 85, suppose that 85 is here. Then the low is going to be 72 here. And then 98 is going to be the high of the day, which is the difference is 13 degrees, I guess. So here is the midline for the sinusoidal function. That is the midline. I'm going to just plot the other lines just to make it a little bit easy to graph the sinusoidal function. We know that at midnight, the temperature is 85. The low is going to happen at 6 a.m. in the morning. So when it's 6 a.m. in the morning, it's going to hit 72 degrees. And then at noon, it's going to go back again to 85 degrees. And then at 6 p.m., this is where the temperature hits the high of the day. And then at midnight, it's going to go back again to 85 degrees. So if you graph it, this is basically the function we're looking for. This is a sine, but it's negative something sine, and I know because the graph goes down, it doesn't go up, so it is negative sine something. The amplitude is 13. If you find the difference between 85 and 72, the amplitude is going to be 13. So A is going to be negative 13, and I know it's negative because the function goes down and then it goes up again. And then I need to find the period. So the period is 24 hours, which is equal to 2 pi over b. And from that I can find b is equal to 2 pi over 24, which gives me b is equal to pi over 12. Now C is 0 because the function clearly didn't move to the right or to the left, but there is a distance that the function moved up. It moved up, which is d. It moved up 85 units. So d is equal to 85. Now to write the equation down. Sorry, I'm very tired, so I'm kind of not being able to focus that much. Sine bx, which is pi over 12 x t. Time is t in this case. You don't have a c, and then plus 85. So that is how you come up with the equation for this problem. A Ferris wheel is 20 meters in diameter and boarded from a platform that is 4 meters above the ground. With the loading platform, the wheel completes one full revolution in 2 minutes. The function h is equal to f of t gives after the wheel begins to turn. Okay, what is the amplitude? I'm going to try to graph this function. So here is a Ferris wheel, and this Ferris wheel is standing on something like that. It is attached here. There is a platform that you can board the Ferris wheel from, and this is 4 meters high. I know that the diameter is 20. That means the radius is 10. So this distance is 10, and this distance is 10, and this distance is 10. I know also that if a person is standing here at time 0, the height of that person is 4. And at time of 2 minutes, because the period is 2 minutes, the height is 4 again. And then when, since it takes 2 minutes to finish one revolution, the Ferris wheel finishes 1 revolution, when the time is 1 minute, the person is going to be 10 plus 10 plus 4, which is 24 meters high. That means after half a minute, the person is going to be this distance, which is 14 meters high. Again, that happens when the time is 1.5 minutes. The height of the person is 14 meters high. So if I'm going to plot this, I know that 14 is going to be the midline, which is D equals to 14. And then the period is 2 minutes. That means half of that is 1 minute. And then half of this distance is 0.5 and half of the other distance is 1.5. So we know that the lower point is 4 meters and the higher point is 24 meters, which is exactly 10. So the amplitude is 10. I can tell that right away. When the time is half a minute, the person is at 14. When the time is 0, the person is at 4. When the time, let me change the color, at 4. When the time is half a minute, the person hits 14 meters high. When the time is 1 minute, the person goes to 24 meters high. When the time is 1.5 minutes, the person goes back to 14 meters. And when it's 2, they go back to 4 meters high. If you graph it, it's going to look like this. Right away, you can see this is a cosine function. The midline is 14, and the period is 2 minutes, as you can see here. So if I wanted to graph this function, if I wanted, to write an equation for this function, I know that the amplitude is 10. And I know this is a cosine function flipped upside down, so the amplitude is actually going to be negative 10, the absolute value of negative 10. So this is a cosine function and it's negative cosine function. Now I need to find B and need to find C. C is 0 right away. And then the period is 2, which is equal to 2 pi over B. B in this case is going to be 2 pi over 2, which is equal to pi. So now I found B. I can write the equation, although it's not required, but let me just write the equation. So it's going to be negative 10, not sine, it's cosine pi t, let's say the time is t, and then C is equal to 0, and then plus 14, which is the amplitude. Not the amplitude, 14 is D, which is the midline. So that is the equation. How high the person is going to be after 1 minute. After 1 minute is right here. The person is going to be 24 meters high. And this is accurate because if you plug t is equal to 1 here, you're going to end up with negative 10 times negative 1 plus 14, which is equal to 24. This function, to determine the function, I just try to graph the sinusoidal function associated with it, and I see this is clearly a sine. That means my function is going to be cosecant, because cosecant is 1 over sine. This function is, the next one is basically a tangent. I know the tangent function. The next one, again, I'm gonna try to graph a sinusoidal function. Well, I have to find the middle point first, the midline first. So the midline appears to be here. This goes up here, and then it goes down here. So yep, this is associated with sine, which means it's cosecant. Now, if I want to find the equation for this, I need just to find everything as if I am finding the equation for sine, and then change the sine to cosecant. So D is equal to 1 in this case. The amplitude is equal to 2. The period length is 6, so period is equal to 6, which is equal to 2 pi over b. That will give me b equals to 2 pi over 6, which is pi over 3. Now we need c. C is 0, so I'm ready to write the equation. So this is equivalent to saying y equals a, and then I change this to cosecant bx minus c plus d. So this is equal to 2 cosecant pi over 3 x, there is no c, plus 1. So that is the equation for the previous function. To identify this, again, I'm going to draw the sinusoidal function associated with this, and it looks like it's a sine, so this is going to be cosecant. This is similar, it's cosecant as well. All right, simplifying. Some of these identities are just simple, some of these are more complicated. So, for example, if I want to simplify these identities, I know tangent is sine over cosine, and I know cosecant is 1 over cosine. So what I basically can say, I can say this is equal to sine x or sine t over cosine t. Everything is over 1 over cosine t, which is similar to saying sine t over cosine t times cosine t over 1, and then I can just simply remove these, and the final answer is going to be sine t. Same here. So I say secant, I see secant, I see cosine, and I see sine. That means I need to write everything in terms of sine and cosine. So this is going to become 1 over cosine t minus cosine t. Everything is over sine t. I'm going to have the same denominator here. I have denominator of cosine, so I need this to have the same denominator. Simply, I will multiply by cosine t, both numerator and denominator. So this is going to become 1 minus cosine squared t over cosine t, and everything over sine t. Or, in other words, this is equivalent to 1 minus cosine squared t over cosine t times 1 over sine t. I know that 1 minus cosine squared t is sine squared t over cosine t times 1 over sine t. So I can simply eliminate one of these signs with this sign. So the final result is going to be sine t over cosine t, which is equivalent to tangent t. The next problem involves tangent. So I know to write tangent in terms of sine and cosine, and it involves cotangent. So I need to write everything in terms of sine and cosine. This is a little bit lengthy, so I will just do it separately. I'll do it right here. So it's 1 plus tangent t over 1 plus cotangent t, which is equal to 1 plus sine t over cosine t, everything over 1 plus cosine t over sine t. Again, I have to have the same denominator, so I can multiply here with cosine t over cosine t. I can multiply here by sine t over sine t. So this becomes cosine t plus sine t, everything over, or the numerator is over cosine t. Everything is over sine t plus cosine t, and the denominator is over sine t, which can be written as cosine t plus sine t over cosine t times sine t over sine of t plus cosine of t. So now I know these are equivalent, and the final answer will be sine t over cosine t, which is equivalent to tangent t. This one, I know that sine t plus cosine t is 1. Sine squared t plus cosine squared t is equivalent to 1. So this is equal to 1 over sine squared t, which can be written as 1 over sine t all squared, which is cosecant, sorry. This is cosecant square, cosecant t all squared, or we can say it's cosecant t squared. If sine x is equal to 1/4 and it's in the first quadrant, we need to find sine 2x and cosine 2x and tangent 2x. So we know that sine 2x is 2 sine x cosine x, and we know cosine 2x is cosine squared. Actually, I can find it only using sine, which is 1 minus 2 sine square x, I believe. Let me just double check very quickly. Tangent is 2 tangent x over 1 minus tangent square x. Now, as visible here, I need to find cosine x and I need to find tangent x. So I'm just going to graph it in the first quadrant. This is x, sine is 1/4, which is going to make this side square root of 15. So if you plug the values here, this is going to become 2 times sine is 1/4, cosine x is square root of 15 over 4. So this is going to become 2 times 2 is going to cancel with 4. So it's going to be square root of 15 over 8. The second one, you just can plug 1 minus 2 times 1 over 16, which is sine square. And that is going to give you 1 minus 1/8, which is 7/8. And then the final one, tangent x is opposite over adjacent, 1 over square root of 15, which is we have to rationalize. So we're going to multiply by square root of 15 over square root of 15. We're going to get square root of 15 over 15. So that is a tangent. So we can find the tangent this way, or we can say basically it's sine over cosine. So it's square root of 15 over 8 divided by 7/8, which is turns into square root of 15 over 8 times 8 over 7, which is square root of 15 over 7. So either way would work. I think this is easier than finding the tangent and playing with this formula. So do whatever you like to do. Both of the methods are correct. Now I need to find the a in degrees. I noticed that cosine square minus sine square is basically the formula for cosine double angle. So this is basically equal to cosine 2 times 39 degrees, which makes a equal to 78, which is 2 times 39, 78 degrees. And then this is the same. I know this is a formula for double angle, so that means this is equivalent to saying cosine 2 times 5x, which makes b 2 times 5x, that is 10x. If cosecant is 1 over 5, that means 1 over sine x is equal to 5, and this is in the third quadrant, the second quadrant, quadrant 2. So we know that sine x will be equal to 1 over 5. Sine is positive in the second quadrant, we know that. So here is x, 1 over 5. And now we need to find this side, which is going to be negative square root of 24. It's negative because this is the negative side of x. And then you're going to use the formulas. So I know sine is positive, cosine is negative, tangent is negative in the second quadrant. So this is going to become positive square root of 1 minus cosine x over 2, which is equal to positive square root of 1 minus cosine is adjacent over hypotenuse. So it's minus square root of 24 over 5. No, not everything over 5, just the 24. So 1 plus 24 over 5 divided by 2, which is going to become, let me just erase this now. This is going to become, we're going to have the same denominator. So it's going to be 5 plus square root of 24, and the 5 goes down. So it's going to be square root of 5 plus square root of 24 divided by 10. And then cosine is the same. So it's going to be negative square root of 1 plus cosine x divided by 2, which is I can just change the sign here. It's going to be negative 5 minus square root of 24 divided by 10. And then the tangent is basically sine over cosine. Or I can say it's negative square root of 1 minus cosine x over 1 plus cosine x. So this is equal to square root of 5 plus square root of 24 divided by 5 minus square root of 24. The math here is basically we're going to have the same denominator, so one denominator is going to eliminate the other one. So this is basically negative sign. So it's negative square root of 1 minus negative 24 over 5. This is 1 plus negative square root of 24 over 5. This is becoming, this becomes 1 plus square root of 24 over 5. So we're going to multiply here with 5, divide by 5. Same here, we multiply by 5, multiply by 5, divide by 5, minus square root of 24 over 5. So this is negative square root of 5 plus square root of 25 over 5, divided by 5 minus square root of 24 over 5. And these will eliminate each other. And then we're going to end up with this answer right here, not this answer. And that's it.